Next, that is Newton-Raphson method. Newton-Raphson method. It is a totally different from the previous three methods. It's the basic is depends upon the differentiation, and this method is the fastest method and provides the most accurate values. Let us see the formula for this. What we use, let xn plus 1 is equal to xn minus f of xn divided by f dash xn. F dash means differentiation of the given function, where n varies from n is equal to 0, 1, 2, 3 and so on. If we put the values of the n, we will get the different step. Let us see a simple problem. Say find the exact root of the function. Say f of x is equal to x cube minus 2x minus 5 by using Newton-Raphson method. Again, the objective is same, but the method is different. Say here it is the given function. So we are facing the again same problem. From where should we start? Where is the approximate value? Here we consider, say, f of 1 that is equal to 1 minus 2 minus 5 that is equal to minus 6 less than 0. F of 2 that is equal to 8 minus 4 minus 5 that is minus 1 less than 0, and f of 3 is equal to 27 minus 6 minus 5 that is greater than 0. Here we stop when the value of the function changes from negative to positive, as we change the value of the variable x from 2 to 3. It means the value lies somewhere near to 2 and 3. No. In this method, we do not consider the both values. We favor the one value, either 2 or 3. We don't say the root lies between 2 and 3. Here we consider that the root lies close to either 2 or 3. That's better if we choose the or select the smaller value. Let us say let root lies near to or close to 2. Close to 2. Here we select only one value, and this value is x0 that is equal to 2. If we will take 3, that's also not wrong. There will be some difference in the calculations, but the objective is again the same. No, we find the differentiation of the function. Say it is f dash x. F dash x is equal to 3x square minus 2. Simple differentiation. F dash x is equal to 3x square minus 2. Now we write the formula for the Newton-Raphson method. Xn plus 1 is equal to xn minus f of xn divided by f dash xn. Here we start, now put n is equal to 0. By putting the values of the n, we get x1 is equal to x0 minus f of x0 divided by f of x0. x0 here we have considered 2, that is equal to 2 minus f of 2 divided by f dash 2, that is equal to 2 minus f of 2 that we have calculated here, that is minus 1, and f dash 2 that will come from this equation, that is 3 into 2 square minus 2, that is equal to 2 plus 1 by 10, that is equal to 2.1, that is equal to 2.1. It is the first value of the rule. Similarly, we can proceed further by putting the values of the n. Now, if we take n is equal to 1, put n is equal to 1, then x2 is equal to, say, x2 is equal to x1 minus f of x1 divided by f dash x1. Then what is x1? Here it is the x1 which we calculated in the previous step, that is 2.1. 2.1 minus f of 2.1 divided by f dash 2.1, that is equal to 2.1 minus f of 2.1. Here we can find it from the function. Our function was that is equal to x cube minus 2x minus 5, that is 2.1 cube minus 2 into 2.1 minus 5 divided by f dash 2.1. F dash from here 3 into 2.1 square minus 2, and we can calculate it. 2.1 minus that is 9.261 minus 4.2 minus 5 divided by 13.23 minus 2, that is equal to 2.1 minus 9.261 minus 4.2 minus 5, that's equal to 0.061 divided by 11.23, that is equal to 2.1 minus 0.061. Divided by 11.23, that's equal to minus 0.0045439. We can approximate it. That comes to be that is equal to, it means say x2 equal to 2.1 minus 0.0054319, that's equal to 2.0945681. So up to 8 or 9 decimal place, the value is available only in the second step. That is the Newton-Raphson method. In the same manner, we can proceed the steps until we get the same values or the approximately same values. That is Newton-Raphson method. Let us discuss one more problem in this Newton-Raphson method. Here the steps we are repeating again and again. This is called the iteration. These are the iterative methods. Means we have to repeat each step again and again to get the required result. No. If we have to find, say, let us consider a problem, write the Newton-Raphson iterative scheme for kth root of a variable of positive number of positive n, and hence find cube root of 10, and hence find cube root of 10, taking initial value 2. Here we are giving the starting value, so at this level we need not to find the approximate value of the variable by hit and try method. Now see, first of all, how to generate the iterative scheme for this, so that we can use this result for each and every problem. Either it is the cube root of 10, square root of the 10, fourth root of 32, fifth root of the 16, any problem of this kind we can solve with this scheme, or in other words we can say we will generate a formula for this, and that formula can solve each and every problem like this. Cube roots of 10, and we have to find 10 raised to the power 1 by 3, or sometimes written in this way, it is like this. Let x is equal to n raised to the power 1 by q, where n is a positive number. Therefore, x raised to the power q is equal to n, taking the qth power on the both sides. Therefore, f of x is equal to x raised to the power q minus n. That is our given function. And if we find its differentiation, f dash x is equal to q into x raised to the power q minus 1, and differentiation for n is 0. Now we will follow the formula for the Newton-Raphson method, that was x n plus 1 is equal to xn minus f of xn divided by f dash xn, where n is equal to 0, 1, 2 and so on. If we substitute these values, it means xn plus 1 is equal to xn. xn comes from here. If we put the value of the x, that is xn. xn minus xn 3 into 2.167 into raised to the power 2. If we calculate it, it will give us 2.154 approximate. Similarly, we can further calculate the steps is to find the value of the variable, that the exact value. It is just like the root, but we can't say it is a root, it is the exact value of the x at the certain point. That's regarding this topic. No, we start with the next.